All right, the Unit 3 Algebra 2 review. Let's get started. Is the following a function? So what we look at is, are there any repetitions in x? In other words, here, 0 only gives me -4. 2 only gives me 6. -1 only gives me 6. 5 only gives me -2, and 4 gives me 0. Now, some of you might notice that there are two 6's here, but it's in the y, so that is okay. 2 can give us 6, and -1 can give us 6. All right, as long as the x's don't repeat. So that's a yes. Now, those two 6's actually help us answer part 2. Because in this one, we have -4, 0, 6, 2, and 6, -1. Because remember, the inverse is just switching the x and the y. So now, we do not have a function for the inverse. Because if you think about it, 6, 2 would be maybe here, and 6, -1 would be here, and that definitely fails the vertical line test. Okay? Is the following table a function? Well, 2 gives us 4 and 2 gives us 6, so that's a no. Is the inverse a function? Well, also no, because 4 gives us 2 and 4 gives us 3. So therefore, no. We're skipping 3 and 4. Determine the type of function. Well, this is just simply y equals 9. If you use the parent family chart we gave you, that is going to be a linear expression, graph, linear equation, sorry. In fact, it's actually a horizontal line. Y equals is always horizontal. Okay, this one, the 3 right here tells us it's a cubic function. All right, number 7 is kind of a tricky one because at first you'd look at it and go, oh, quadratic, because of these little 2's right here. But if you look at it carefully, 2x squared minus 2x squared cancels, so what we have is y equals 2x, also known as 2x plus 0, which makes this linear because our exponent is 1. Oh, I screwed up. Number 6, I forgot to add a root on that one, so it should be cube root. Sorry about that. Number 8 is cubic. Okay, number 9 through 12. Again, these are in your notes. You can use your notes on the test. There's no reason to get these wrong. Just look for the patterns. Another thing you can do, since you have access to Desmos for this test, is you can put these points in Desmos and you will see what's happening. Now, you also want to look for some patterns here, like see this -8 here and here. Okay, so if you have -8 at 2 different points, you know you're probably going to have something like a parabola or an absolute value because of just the general shape of it, right? And if you actually put this in Desmos and you did -2, -8, and -1, -10, and then 0, -8, and then 2, -4, and 3, -2, you would see that you have an absolute value equation. So that's another way to work around this without getting this wrong. But otherwise, let's look at the pattern of what we see here. Okay, with -8 to -10, it's going up +2. And -10 to -8, sorry, it's going down -2. My mistake. Then it's going up +2 and +2 and +2. If you don't look all the way through this, this part looks like a line. And it is a line. Okay? But it turns around and has a line going the other direction and it's absolute value. So again, put these in Desmos if you want. Okay, if you're not good with patterns of adding, subtracting, multiplying, dividing, use Desmos. All right, so what's happening here? Okay, well, we are adding 12, and then we're adding 2, and then we're adding 3, and then we're adding 14. Nothing really helps there. Okay, if you go on the other pattern, the other side doesn't really help you. But again, if you put this in Desmos, you will see that you're going to get, -4, -13, say down here, -2, +1, 0, 3, 2, 5, 4, 19, and you will see you have a cubic function. Okay, that's a trickier one because it doesn't have follow the same patterns we did in the assignment. All right, this one's a little bit easier. 12 to 6 is -6. Then -12. -6. And -6. Now, this one's tricky because if you notice here, it skipped over 2, and that would have actually been 2 zeros, so it would have been -6, -6, -6. So again, this is kind of a tricky one because it throws in that -12 there, but that's because this wasn't consistent over here. So this is linear. But again, if you want to put this in Desmos, it'll make it very easy to not get it wrong. Okay, now this one, 1/9 to 1/3. We're actually multiplying by 3. And then times 3 here, and 1 times 3 is 3, and 3 times 3 is 9. So this is exponential. And actually it's growth, if you want to be more specific. All right. What does the transformation here mean compared to the regular f of x? So again, I highly suggest you use your Desmos or graphing calculator here. Okay, go to y equals, clear out whatever you have in there. And I would, since you just have an x to the 1 here, okay, then your original equation is just y equals x, a linear equation. Okay, so what we're going to do now is look at what happens if we had 1/3, 1 divided by 3, negative, sorry, -1/3, and then parentheses, x minus 2. I think there's a typo there with that f. That shouldn't be there. So you can tell it's reflected or flipped. Okay. Now, it does not move down to, okay, because it is not outside, it's inside the parentheses. So you gotta be careful with that one. Now, this is a tricky problem because there's some parts of these that are right, okay? So it's not translated down to, that's for sure. Okay, the -2 would have to be outside the parentheses. All right? It is not moved left to, because remember, inside lies, so it actually moves right to. So it cannot be A or B. All right? With the negative outside here, it is reflected over the x-axis, not the y-axis. Now, like I said, it is actually moving right 2, but it's not over y. So by process of elimination, it is C. Okay, what's happening here? Well, this 2 on the outside vertically stretches it. And I'll be honest, these are harder with linear because what does it mean to stretch it or compress it? It's harder to think about with line as opposed to a parabola or an absolute value. So use the chart in your notes. And the plus 4 on the outside means up 4. Okay, number 15. What happens between these two? Well, the plus 3, remember, inside lies, so that's left 3. Negative 4 on the outside means down 4. Which of these following is a good graphic representation? Well, absolute value, it's going to be a V shape. Okay, so let's think about just some common sense. 1/3 is positive. That means it's going to be wider. Okay? And also it's positive, so it's not going to be upside down. So let's rule that one out right away. Also, the negative 3 on the inside lies, means right 3. So if you look at this one here, for one thing, it's actually narrower, and it's up 3. So that's completely opposite. Now these two choices, C and D, are both wider. This one is left, and this one is right. So we want to go with D, right 3. Again though, if you just put in your calculator here, okay, remember absolute value is under the math key, number, right there, and you just put X. Whoops. Thought the X stuck around. And then down here, for number 2, we put 1 divided by 3, and you can do this in decimals also, and then hit math key, number, absolute value, X minus 3. There's no reason to get these wrong. There's the original one, and look at here's wider and to the right. Okay, so please use your calculator or Desmos and don't get these wrong. All right, piecewise, I'm going to show both ways. So if you like to graphically, actually physically write these down and then erase part of it, you can watch the first part. If you don't like to do that and you like to use the calculator to your benefit, you might want to fast forward a little bit till I start over. Okay, so first off, remember, if it helps, this is y equals negative 3x plus 2, y equals 3 absolute value x minus 1, whoops, and y equals 2x minus 4. So you have 2 linear equations and an absolute value. Let's not worry about this yet. Okay, remember that part is what we're limiting. So negative 3x plus 2. Negative 3x plus 2 has a y-intercept of 2. So let's put that right here. And then a down 3, 1, 2, 3, right 1. 1, 2, 3, right 1, and so forth. Or up 3, left 1. Like so. And that gives us this line. Now we're going to look at our limits. It says there's going to be a wall at x equals negative 1. That's right here. Okay? So what we're going to do is look where it hits at that point on that imaginary line and cut it. Now we want x less than -1, which means we want the left side. So we're going to get rid of the right side of the line. Okay? Now the next one. Absolute value 3 times x minus 1. Okay? You can go to your calculator and get some points for here, or you can just plug points in. All right, so if I plug some points in, 0 minus 1 is -1. Absolute value of -1 is 1 times 3 is 3. So that's 0, 3. All right? If I did 1, 1 to minus 1 is 0. 0 times 3 is 0. If I did 2, 2 minus 1 is 1. 1 times 3 is 3. So you can already see the shape of this absolute value. So it's going to be something like this. But we only want it between -1 and 2. So we want it using that black line there and also another one right here. We want in between that. So we don't want any of this. And we actually don't want, it'll be a little tricky here, any of that. And notice it has a less than symbol here. So they're going to be open dots. So if we want to kind of clean this up, whoop, that was a big mistake there. It's not grabbing what I want. All right. So if I look at this, again for the red one, I wanted a big old solid dot right there. At -1, +5. And that's going to be this line right here. Okay. For the green one, I want in between -1, but I don't want it to actually hit there. So remember, -1 gives me -1, 6. So that's an open dot right here. Let me clean this back up. Okay, so I also want an open dot here. So it's going to be an open dot here and an open dot there. Now, my last one is going to be 2x minus 4. So again, that's going to have a y-intercept of -4 right there. And it's going to have a slope of 2. So up 2, right 1, up 2, right 1, and so forth. That's going to look like that. But I want to start it at 2. So that's where my imaginary line is going to be, is at 2. So that was at 2, 0, which means I don't want anything down here. the sensor is really off for some reason today. So I want a solid dot right there. So notice at -1, I have a solid dot right there at -1,5, and I have an open dot at -1,6. Over here at 2, at 2, 3, I have an open dot, and at 2, 0, I have a solid dot. If they're lined up underneath each other, one has to be open and one has to be solid. Okay? So, that is our piecewise function. And then it says evaluate, -3. Now, there's a few ways to do this. You can actually come out to -3, 1, 2, 3, and go up and down and see where it hits. Sometimes it'll be off the chart. The other way is just look up here. -3. Which one does that fall under? Well, -3 is less than -1, so I'm going to plug that into the first one. So that's going to be 9 plus 2, which is 11. So actually, if I was just trying to use the graph and went over 3 and went up, I'd have to guesstimate because it's off the chart. Okay, f of 2. Well, that one's a tricky one because if you look here, you think, oh, it goes there. But remember, that's less than 2, not less than or equal. So it has to be the third one. So that's going to be 2 times 2 minus 4. And that's actually one of our points. So that's 0. And now where would 4 be? Well, that's greater than 4, so that's going to be plugged into the same one. Four, 4. That one we could have found on the chart. Right there. Now, the other way to do this, which I think is a little bit easier and beneficial using technology, is use Desmos or your graphing calculator. So for the first one, -3x plus 2. So I'm going to clear out what I have here. I'm going to put in -3x plus 2. -3x plus 2. And graph it. Okay, that looks familiar. Now, if I go to my table, I want numbers less than or equal to -1. So I don't want 0 or 1 or 2. So I'm going to put -1 right there at the bottom. And then I would just plot those points, -1,5, -2,8, and that's pretty much it because it's off the chart. So -1,5, -2,8. So there's -1,5, there's 8, and I just make my little arrow right there. And then for the next one, 3 absolute value x minus 1. That's not what I wanted. Y equals, clear it out. 3, math key, and again, if you're using decimals, that's fine. Absolute value, x minus 1. Graph. Okay, that should look familiar. Now, I want between -1 and 2. So I'm going to move this to where -1 is at the top, and I'm going to get these 1, 2, 3, 4 points. -1, 6, 0, 3, 1, 0, and 2, 3. And use open dots. So -1, 6 is right here, open dot. 0, 3, right here. 1, 0. And then 2, 3, open dot. And then I connect like so. And then my last one, 2x minus 4, clear out what I have. 2x minus 4, graph. There's my line. look at the table, I want numbers bigger than 2 and equal to 2. So I'm going to move this to where 2 is at the top, and then I put it 2, 0, 3, 2, 4, 4. So 2, 0, right here. What was it? 3, 3, 2, and 4, 4. And there's my line. Okay? That's my piecewise graph. Parts of two lines and parts of an absolute value in between. All right. Given this graph, which function is not represented? So you just got to look. So here we have a line, absolute value, and a parabola. Okay? Now, over here, I'm just going to put some code here. This is a line. This is going to be a parabola. That's going to be absolute value, parabola, absolute value, and a line. Now, notice my line has a negative slope. Okay? So A and A and F both have a negative slope. But let's do the slope. Let's calculate what the slope is from here to here. Okay? So if we go up 1, 2, 3, 4, left 2, or actually there's a point right here, so we can just go up 2, left 1. That is a slope of negative 2. Right? So therefore, that's F. So we know this is not our choice. Okay? Now, our absolute value. Notice, here's where it should have a vertex, but the vertex is right 2. Okay? Right 2, which means we should have minus 2 in the absolute value bars, like so. Not here. And this parabola, the vertex is moved over 1, 2, 3, 4 to the right. Okay? So that's minus 4. And another reason this one is wrong, that means up 4. So it says, given the piecewise graph, which function is not represented? Well, that would be A, C, D. Okay? So A, C, and D. Now, negative 1. It's asking us, what does negative 1 give us? Well, if we go to negative 1 and go up or down, if we go up, that's an open dot. And I'm telling you right now, there's one like this on the test, so pay close attention. We don't want the open dot. We want this point right here at negative 1. What about positive 1? Well, there's nothing below it. There's a point right there at positive 1. We don't want open dots. Okay, so be careful with that. Find the inverse of each of the following. So remember, step 1, change this to y. Step 2, switch the x and the y. Step 3, get this by itself. So we're going to subtract 12. And then get rid of the negative 4. So that's y equals x minus 12 over negative 4. Or technically, f negative 1 of x. You can write it either way. That's your answer right here. And no, you cannot just cancel the 4 into the 12 because it's a binomial on top. Okay, same thing here. Y equals 4x minus 8. X equals 4y minus 8. Add 8 to both sides. Divide by 4. Y equals x plus 8 over 4. And no, it's not x plus 2. You can't do that. Find the inverse. Same thing. Okay, switch negative 3/5 y plus 6. Minus 6 from both sides. The way we get rid of a fraction is multiply by the reciprocal and keep it negative to cancel. Careful here. So y equals, and you can leave it like this, negative 5/3 x minus 6. You do not have to distribute. If you want to, that's going to be plus, negative times a negative. 3 goes into 6 2 times 5 is 10. Either one of those is fine. Okay, make this y. Switch them. Cube root of 2y plus 3. First thing we need to do is get rid of the cube root by cubing. X cubed equals 2y plus 3. Then we subtract the 3. And divide by 2. So y equals x cubed minus 3 over 2. Final answer. Okay. Given the following functions, find the indicated compositions. So remember, we're going this way. So we're plugging g into h. So we're going to write 2 something minus 1 and just put x squared plus x plus 3 in here. So g went into h. Then we just distribute our 2 to each spot. Remember, the 2 does not go to the negative 1. It's outside the parentheses. Then we just join like terms. That's it. Okay. This time, we're doing h into f. H into f. So that's 3 times something plus 4. Don't forget this. That's the most common thing forgotten, which is why I do it like this. Then I fill in my x substitution. Distribute 6x minus 3. Leave the 4 alone. Combine like terms. 6x plus 1. Okay, next one. Again, we're going this way, so h into g. A little more work here. H into g, here and here. So, 2x minus 1 squared plus 2x minus 1, that's my x, plus 3. Now, there's 2 ways to do the 2x minus 1 squared. You can come off separately off to the side and just FOIL it, or double distribute, whatever you want to call it. 4x squared minus 2x plus 1. Notice that these are the same, right? So you just join like terms and you're done. The shortcut is very easy. You square the first term, 4x squared. You multiply these and double it. Minus 2x doubled is minus 4x, which is what we would have had right here, minus 4x. And then, last times last, or just square this, plus 1. Okay, and then the 2x minus 1, and then the 3. Now we just join like terms. 4x squared is by itself. Negative 4x plus 2x is negative 2x. 1 minus 1 is 0. So the plus 3 just stands. Last one, we're putting f into g. And if it helps you to do this, do it. F into g, here and here. Again, this is a little bit more work. So f, which is 3x plus 4, squared, plus 3x plus 4, and then again, plus 3. You don't really need to have parentheses here since it's a plus. It's up to you. So I'm just going to do the shortcut here. Square the first, multiply 12x, double 24x, square the last. And then the 3x plus 4 and the 3. 9x squared is by itself. 24x plus 3x is 27x. 16 plus 4 is 20, plus 3 is 23. Final answer. Almost done. Determine if they are inverses of each other. So what we're going to do is plug this one in here. So 1/3 times 3x plus 3 minus 3. Okay. Well, if I distribute, I get 1/3 of 3x is x. 1/3 of 3 is 1 minus 3, and that gives me x minus 2. I'm done. I don't have to go any further because I did not get just x. So it's no. Now, just for the heck of it, let's see what would have happened if you went the other way. If you did 3 times 1/3 x minus 3 here, plus 3, let's see what would happen. 3 times 1/3 is x, minus 9 plus 3, x minus 6. Again, you don't get x. But you don't have to do it both ways. Once you get a no, you're done. Okay, let's try this one. Be careful here. This root is not over the 8, negative 8. So I'm going to plug this in right here. The cube root of x plus 8 cubed. Also then minus 8. So this cube undoes the cube root. The cube root undoes the cube. That leaves me just x plus 8 coming out, minus 8. Those cancel. I'm halfway to a yes. Now I'm going to plug this in here. So I'm going to have the cube root of x minus 8, whoops, plus 8 cubed. Well, right off the bat, the 8's cancel. So that gives me the cube root of x cubed. They undo each other. X, yes. All right, last one. This goes here. So negative 1/2 times negative 2x minus 4 minus 2. Don't forget that last part. Distribute this here and here. Negative times negative is positive. Half of 2 is 1. Negative times negative is positive. Half of 4 is 2. Those cancel. Boom. Halfway to yes. Now I'm going to take this and plug it in there. So negative 2 times negative 1/2 x minus 2 minus 4. Distribute. That's going to make the negative 1/2 positive x. This is going to become positive 4. The minus 4 cancels. X. Yes, they are inverses. And that is it.